Yeah.
Yeah. Yeah.
All right, we're about to begin. Can everyone return back to their benches? Thank you. And also, this workshop will be recorded due to this lab being full. Would you guys just come in? You guys make the lab is full. It will be recorded. All right, listen up. This is the Quad 1 Oscilloscope workshop. So in this workshop, I'm assuming all of you guys are doing Quad 1, right? Put your hand up if you're not. Okay, yeah. So this workshop will cover basically everything you'll need in your lab exam. So that's how to set up your oscilloscope. That's how you measure. That's how you trigger your oscilloscope. That's how to use your cursors. And that's also, we also have a little activity at the end for like a mock lab exam question, pretty much. So we're going to start with how to set up your oscilloscope in the beginning. So when you walk into your lab exam, the first thing you want to do is click on default setup. This button right here on your oscilloscope. Can everyone press that right now? All right, once you've pressed default setup, you also want to make sure both channels are set to 1-to-1 on your oscilloscope. So to do that, to set your channels both to 1-to-1, we want to click on the actual channel, clicking here, and you click on probe, click here, and make sure it's 1-to-1, using this knob to adjust it. Put your hand up if you're having any troubles with adjusting your probe 1-to-1. All right, we'll be moving on to basically everyone have their oscilloscope set up, so that's 1-to-1 and default set up. Is that done? All right, let's move on to how to use the scales. So there's two very simple basic things to know about the scale. Your big knob is your dilation. That's either horizontal dilation or your vertical dilation. And your tinier knob, that tiny knob is responsible for your offset. So that's horizontal offset or vertical offset. So to change your horizontal scale, you would use this big knob right here. So if you can see on your top right corner, my scale is changing as I move that big knob. And to change your vertical scale, it's that big knob on your vertical, on channel 1 to change my vertical scale. The tinier knobs are horizontal scale offsets. So I'm offsetting my triangle wave right now. And you can also press on that tinier knob to zero it. So if you have a delay of 500 milliseconds, I can press on this and it returns back to 0. This is also the same for your vertical offset. If you have a vertical offset, you can also press on this to 0 it. Is anyone confused on how to use the horizontal scale and vertical scale? Right. Everyone here knows how to use the scale to change your vertical scale and also your horizontal scale? All right, that's great. We'll move on to our first activity then. So on your signal generator, could you set a sinusoidal input of 4 volts peak to peak at 2 kilohertz? Then change your horizontal scale to 1 microsecond, and the vertical scale 2 volts per division. Yeah. Alright, if you're having any troubles, I'll do this whole thing on the screen. So first, we want our peak to peak to be at 4 volts peak to peak. Now do that by changing our actual signal generator. So I can read my peak-to-peak voltage after I press measure, and that's around 4 volts peak to peak. We can now change our frequency. What's the frequency? 3.45. Yeah. And then also change to a sinusoid. What's the frequency? I think it was different on the slide. 2 kilohertz.
I got it from he did ELEC1111. Right now he's doing physics everything. He's doing everything.
Alright, if everyone's done the first activity properly, it should look something like this on the screen. So here, I've changed my vertical scale to 2 volts per division. I also have my horizontal scale at 10 microseconds. And I'm going to adjust that so I can actually see my signal. If you want to see your peak-to-peak voltage, just press measure first. We'll cover this more in depth later on. Does anyone have any questions on how to modify the scale, like manipulating the scale with the oscilloscope? Anyone? We'll move on to triggering.
One trigger. Slide.
Alright, everyone listen up. I'm about to cover triggering, which is a very, very, very important concept in your lab exam. So I'm sure when you guys have done your labs, you see your oscilloscope on the screen, and it starts going crazy, right? That's because of triggering. So if I have my trigger, it spazzes like this on the screen, right? Has anyone ever seen this when they've done the lab? Yes? That's because we haven't set our trigger properly. So does anyone here know what a trigger is? No? Give a guess. Sure. So our horizontal axis on our oscilloscope is time, right? But what defines time equals 0? What tells the oscilloscope to start capturing the signal at time equals 0? So the trigger is a set of conditions that we define to tell the oscilloscope to start acquiring a signal and displaying it on the screen. That's centered at time equals 0. So our trigger can set our trigger conditions on this side of your oscilloscope. So press trigger, and you can use this to adjust the trigger level. So what this does is, when the oscilloscope detects a signal that crosses that trigger level, it will start capturing the signal and start displaying it on the oscilloscope. So what happens, can anyone guess what happens when I have my trigger level outside of my signal? It starts spazzing out again, right? That's because our oscilloscope isn't detecting any signal that's passing that trigger level voltage level. So it'll start capturing anything it detects and triggering it on, putting it on the screen. That's why when my trigger level is outside of my signal, it starts going crazy like that. Does anyone have any questions so far? No? All right. So another thing to know about the trigger is the trigger edge. Does anyone remember from lab 5 what the trigger edge is? So the trigger edge, your trigger level can be passed either from low to high. You can pass the trigger edge, trigger level from low to high, or from high to low. So either on the rising edge or on the falling edge. You can change whether your oscilloscope triggers on the rising or the falling edge by changing the trigger type over here. Clicking on trigger type edge and the slope, you can change that to the falling edge. And you can see the oscilloscope start triggering on the falling edge when I change it to the falling edge, or the rising edge when I change it to the rising edge, like so. All right. Does anyone have any questions on how to trigger the oscilloscope? We'll move on to an activity right now then. So if anyone is stuck, I'll just go through how to do the activity real quick. So I want to change my peak-to-peak voltage to 5 volts. I'm modifying it on the signal generator. So now it's at 5 volts. I want a triangle wave, so I'll click on the triangle button on the signal generator. And I want 11.11 kHz or something around that. So what I want to do is increase my frequency to 11K. Right now it's maxing out at 5, so I need to click on the 10K button so the oscilloscope can go up higher. And now I have it at approximately 11K. So to trigger this triangle wave, we want to modify the trigger. Like so. All we need to do is move the trigger level inside the signal. And display the signal at an appropriate number of periods. So I'm going to put about 2 or 3 periods on here. Does anyone have any questions about the activity? Anyone? You guys all following? Alright, yeah.
How can we set the trigger level to 2? Like, where can we see that it's 2 volts?
Oh, so you just move this trigger, and this will come up, this line will come up on the screen, and just move it up and down. You can see on the top right corner what the voltage level is. So right now it's at 1.05, and I can just move that up and down.
Do we need to use the falling edge function on this?
I'm about to cover that.
Okay.
Yeah. So going back to the trigger, can anyone guess what happens when I move my trigger from the rising edge to the falling edge? Anyone guess what happens? It flips. Yeah. So right now my trigger's on the rising edge, and you can see that's being centered on the rising edge. So when I change my trigger to the falling edge, you can see that it flips, and it's now being centered at the falling edge of the signal rather than the rising edge. Does anyone have any questions on triggering?
Yeah. What are we meant to set the trigger level to? It says 2.
2.
Yeah. Is your amplitude high enough to 5 or 3 trigger level?
I can see that most people have finished the activity. So also look at the question down the bottom, which is what the difference between trying an offset on the oscilloscope versus an offset on the signal generator. Can anybody guess what the difference is? Anyone want to give it a go? Alright. So an offset on the oscilloscope, your oscilloscope is a measuring device. It doesn't change the actual signal that's being inputted to it. It only measures it. So the offset is purely a visual thing on the oscilloscope. Wait. So if I change my offset on my oscilloscope, it's purely a visual thing. It's not actually changing my signal that's being inputted. But if I change my offset on my signal generator, it will change the actual signal on my oscilloscope up and down. That's my actual signal. It's not a visual thing on the oscilloscope. All right, we'll move on to another activity about trigger. All right, this activity basically covers everything that I've talked about so far, the trigger. So if you can attempt that activity, and I'll go through that later on. Has everyone tried having a go at the activity? All right. Oh no, that's okay. Can we switch back to this?
the camera.
Alright.
You just have to put
Alright. If you haven't gone through the activity, I'll go and walk through the whole thing with you. So the first thing we want to do is set the trigger mode to auto. So I'll do that by clicking on the trigger button over here. The mode is on auto already for me. And now I want the trigger level to be at positive 500 milliwatts. By moving my trigger and looking at the top right corner, moving that up to positive 500 millivolts. So now it's at 500 millivolts and it's triggered on auto mode. I'll input a 2-volt sinusoid peak to peak over here. So I'll change this to a sinusoid. Then I'll have it at 2 volts peak to peak by decreasing the amplitude. And I'll change the frequency to 3.45 kilohertz. All right, did everyone follow that? I've had it all set up. So the next part of the activity asks us to slowly increase the trigger level past 1 volt. Can anyone guess what happens to the oscilloscope? The signal displayed on. It spazzes out, exactly. Does anyone know why it spazzes out? Exactly. It's trigger on anything it sees because it can't find the trigger condition going past 1 volt. So in an attempt to re-trigger this oscilloscope, usually the best way to do it is setting our oscilloscope to normal mode for the trigger, and also moving our trigger level down into our signal so it's being displayed on the screen. So to reiterate, usually to re-trigger your signal, normal mode, and moving our trigger level down into your actual signal. Does anyone have any other questions about this activity? Yes? So normal auto mode, the oscilloscope sometimes automatically captures it for you. But normal mode, it's defined just by your conditions only. So sometimes the oscilloscope automatically captures it for you. So if I go into normal auto mode, right, it becomes like this. That's because the oscilloscope is automatically capturing, it's automatically triggering on any signal that it detects. Yeah, normal mode. If you're having trouble with auto, this is still on normal mode.
what do you want?
Measure, yeah.
You want this thing?
Yeah. All right, listen up. We're about to move on to the measurement portion of this workshop. So can everyone construct a circuit on the breadboard? You'll need a 100 nanocapacitor, which is found at the far back of this workshop. And you also need a 680 ohm resistor, which is also at the same location. Let's put this up.
It's pretty hard to see.
Yeah.
But it is pretty hard to see.
That's fine.
You want to just put like when you get to, I'll keep switching back and forth.
Does everyone have the circuit set up on their breadboard yet? Put your hand up if you're having any trouble setting up your circuit on the breadboard. If you look on the screen, there's an example set up of the same circuit on the breadboard. That's 3 p.m. Oh, N.
Okay, like at the end of the corridor. I'll find it.
Oh, yes. All right, now that everyone has the circuit built on their breadboard, we'll use the same 2-volt peak-to-peak sinusoid from the last activity, using the same 3.45 kilohertz frequency as before. So using that, ignore the phase difference for now. Using that, can you try and measure the peak-to-peak voltage and the frequency on your oscilloscope? You want me to walk through? I'll walk through doing that with you guys. All right, the first thing you want to do is press the measure button. The measure button is located right here on your oscilloscope, labeled MEAS for measure. You click on that, you click on the source, the channel you want to measure from. So in this case, we want to measure channel 1. Measure the frequency type, so we click here. We want to find peak to peak. That's at the top. We click on that. After that, just click on add measurement, and you can see our peak to peak voltage at the bottom right here. To measure frequency, we do the exact same thing again. Click measure, type, find frequency, and add measurement. If you don't have a complete period on the screen, you might want to zoom out a bit. So as you can see, I'm really zoomed in. If I zoom out to show a full period, my frequency shows up on the screen. So in your own time, try and measure the frequency and the peak-to-peak voltage on the oscilloscope using the measure function. Has everyone measured their peak to peak as well as their frequency on their oscilloscope? Put your hand up if you haven't done that yet. All right, now we'll actually use our breadboard circuit, and instead of measuring the frequency and the peak-to-peak voltage of our source, we'll do it for our 680 ohm resistor. So can you switch on the screen? So our 680 ohm resistor will measure the frequency and our peak-to-peak voltage on it. So what we want to do is connect our signal generator source onto our breadboard. Like so. So breadboard is now powered, and we'll now measure the frequency and our peak-to-peak voltage across our 680 ohm resistor. To measure voltage, we'll put it in parallel with the resistor, like so. All right, we'll move on to measurement using cursors. So using cursors can measure the exact same thing that we've done. The measure. So next to our measure button, we also have our cursors. We can use our cursors to measure our peak-to-peak voltages as well as anything else that we want. So if we click on cursor, we have these options here. If we click on this option on the cursors, we can select which cursors we want to use. So there's 4 cursors. There's X1, X2 for the X-axis, and Y1 and Y2 for the Y-axis. So if we want to use our Y1 and Y2 cursors to measure our amplitude, we'll first select Y1 to move our cursor for Y1. So I selected Y1. I'll click on it. I'll use this button over here to move our Y1 cursor. I'll place that at the very top of our waveform. For the same thing, I'll use Y2 and place that at the very bottom of our waveform. So I'll click cursors, click this button over here to select Y2, and use this to move our Y2 cursor onto the very bottom of our waveform. So now, on our oscilloscope, we can see this here. Delta Y gives us negative 1.47 volts. And that's our peak-to-peak voltage over our 680 ohm resistor, using cursors rather than measurement.
No, this one's Delta Y. At the bottom.
Those are like
That's why
tight huddle
second.
No,
that's the one. Oh, okay. Yeah, right.
Alright, this is a track waveform activity.
Alright, has everyone had to go with this activity? We'll move on to the final function of our cursors. So our cursor also has one more very special important function, which is track waveform. Listen up! So our cursors can also be used to track our waveform to find a specific point in time where the voltage is at a specific level. So if I go to cursors, I can click on the mode and change that to track waveform. So when I move my cursors, it will automatically trace the waveform with it. This is especially useful when I need to measure something like 5 tau. So if I have a natural response of our RC circuit and then find the point where it's approximately 0, I use my track waveform and I move it along with the waveform until where it's approximately 0. So if any of you haven't done lab 6 already, you'll need to find 5 tau in lab 6. You can use track waveform to get an accurate measurement of where 5 tau is approximately 0 volts.
Yeah, activity.
Yes. Wait, Josh? Yep. Go change the slide to like.
Which one?
Just like picture of the thing.
Just go back.
Yeah, yeah.
So right now, to prepare for our next activity, we want to change our sinusoid to a square wave.
And it really helps having this further up.
Alright. We'll move on to our math function since everyone knows how to use our cursors and also track waveform. So what if we wanted to measure the voltage across our capacitor? So recall from the very first lab 1, that we can't measure this capacitance directly because our oscilloscope is internally grounded. So what happens when I put my black probe across this point? That is grounded and shares the same node as ground here. So a current will flow through this capacitor and completely bypass this resistor over here, which basically changed our circuit to this circuit rather than this circuit. So to prevent that from happening, we want to use our math function to measure this capacitance rather than directly measuring it with our 2 probes, because that would change the modified behavior of our circuit by bypassing the resistor over here. So grabbing another BNC cable, we'll put that into channel 2. So to prepare for that activity, make sure you have a second probe. You have one probe measuring V in, so that's across the whole thing, and also another channel measuring the voltage across the resistor. So one probe measuring the whole thing, so voltage in, and another probe measuring the voltage across the resistor, like so.
What? Yeah, we have like one just one of the. That's the resistor. The channel one is the resistor. Channel 2 is the. The skills are singing is on top of the screen. I went to the bathroom when we were doing it on that. What else?
All right, so I'm about to walk through this entire activity. So look on the screen to see how to do it. So first thing you want to do is click on the math button. Our math button is located here on the waveform. Now click on it. Since we want the voltage across the capacitor, that is our whole voltage minus the voltage across our resistor by KVL. So here we want to minus our waveform. I'll modify that with subtract. And all it is, this will subtract waveform 2 from waveform 1. In my circuit, I have on channel 2, I have V in. So I'll set that to the very top. I'll change source 1 to source on top. And source 2, I'll change that to 1. So now I have 2 minus 1. So I have channel 2, waveform, minus channel 1. So I can get V in on channel 2, and the voltage across the resistor as channel 1. That's why I have it as 2 minus 1. Also, on our math function also has its own separate offset and its own separate scale. You can check our scale on our math function by clicking on math. On the bottom, these bottom two options here on math is our scale for our math function. So right now, I have an offset. I can move that offset, and I can also zero it. Make sure you zero that offset on the math function. I also have my own scale for my math function. I can also change that. Make sure your scale is the same as these two scales that you used.
I'll let them kind of cook this.
Does anyone have any questions on using the math function? Any final questions on using math?
Okay. Yeah. You're doing it. No. That's like.
So that's why I like half the questions you ask.
Wait, no, I just want like something cool on the oscilloscope.
That's really good. Okay, I'll transition.
That's what that resistor value is. Do the one circuit back to setting 1.2. Done.
That then goes into the stuff. And then goes into this resistor. Okay. So the second capacitor and the second capacitor. Now it says naturally the frequency 11 to 5 Weird.
Trying to trigger something.
No, just try and get the original waveform
500 what?
up.
5K hertz. Yeah,
Oh, just press.
What's it like?
Press that.
So over. Default setup.
no. It's for the frequency band.
Are you trying to do that trigger one?
Yeah.
Oh, you just did. And you want us to.
Yeah, and then press it. 1 minus 2. Minus, 1 minus 2. Yeah, this is a nice phone.
5K to 5,000.
Yeah, this is nice phone. Oh, edit it.
I'm not playing it.
I'll edit it. It's not that hard.
No, it's not.
Yeah, but I want to mute. I want to mute. I'll go. Yeah. Well, I can have some Michael can do it.
Oh, then I'm gonna have to. That's the hardware transfer.
At that point, it's
Oh, yeah, yes. No. Yeah, it's in there.
Maybe I should put a slide that says thanks.
You can add that as a filament.